who is currently employed as the Senior Principal Scientist of Platform Group, Industrial Specialties of Ingevity, located in North Charleston, South Carolina. He received his PhD degree in polymer chemistry from Virginia Tech in 1998 and an MS degree in dental material from The Ohio State University in 1995. He has over 20 years work experience in coating, composites, ink, and toners for new product development. He has authored over 30 papers on the polymer science and technology and has several patents. Please join me in welcoming Dr. Yongning Liu.
Thanks, Rick. Everybody can hear me? Hello?
Yes, we can hear you.
Okay, good. Good morning, everyone. And thank you, Rick, for the introduction. My name is Yongning Liu from Ingevity. Today, my talk is the environmental friendly bio-based distilled epoxy resin performance. Distilled means this distillate tall oil, and I will show you later on. Ingevity is a leading global manufacturer of specialty chemicals and high-performance carbon materials, and creating high-value added product from renewable raw material. Ingevity include two major parts. One, the performance materials, is namely the carbon technology. Another part, the performance chemicals, and include 4 different divisions. Pavement technology, oil field technology, industrial specialty. This is the division I work on right now. We make adhesive, textile, chemicals, lubricant, ink, and intermediate. Another division, engineering polymers. The agenda of my talk today, the background information, detailed epoxy resin properties, and Jefferman cure detailed epoxy performance, and anhydride cure detailed epoxy performance, summary and acknowledgement. So thermoset resin is a material after cured can form 3-dimension cross-linking structure that is not soluble in solvent and not melt when heat up. By Kuhn mechanism, there are 2 categories thermoset resins. One is called condensation thermoset, 2K epoxy. It's widely used in coatings, structure adhesive, composite, and ester and BMI reagents. And ester and BMI reagents mainly used for advanced composite. So free radical cure thermoset include unsaturated polyester and vinyl ester. The both material is mainly used for composite application in the market. And using acrylate, epoxy acrylate can use for UV cured and E-beam cured. So approach to bio-based building block. The biosource include food base such as starch, vegetable oils, egg byproduct, industrial co-product such as rosin, tall oil fatty acid, lignin. This is the Ingevity made material every day. So the question is how to convert this biosource into useful the monomers and polymers. The one way to make this happen is the modification. Example, vegetable oils is widely used in alkyd coatings, but they make the modification first, right with glycol to make hydroxy terminate oil ester, then react with others to make alkyd coating resins. The bio-based monomer can go through the biorefinery. I'm going to show you next slide. This is Ingevity make the bio-based materials. The last one is produced directly by bacterials. So this is a biorefinery, and starting with renewable trees, goes through the pulp mill. The pulp go to the paper company to make papers. The liquid part neutralized by sulfuric acid, then followed by centrifuge separation to produce called CTO, the crude tall oil. This is the ready bio-based raw material fed into the biorefinery, goes through the vacuum distillation. We can generate three major bio-based material. The tall oil fatty acid is a light yellow color liquid at room temperature, and it contains less than 1% or 5% rosin, and determine this how high the grade for tall oil fatty acid. And tall oil fatty acid majorly used for lubricant, used for detergent and soap and coating applications. And next product we produce through this biorefinery is called distilled tall oil. This is we focus on today to make epoxies raw material, and we call DTO. It is combination rosin and the fatty acid. And room temperature is liquid, and the color somewhere around like yellow and the light brown colors. Depending on how many percent the rosin in the DTO, we have different product. Example, M28B mean they have 28% by weight rosin in DTOs. Another 72% is most likely this fatty acid. And another product goes through the process. It's called the tall oil rosin. It's glassy amber color, solid and room temperature. It's widely used as raw material to make ink retins and make textile for adhesive. This is a chemistry for DTOs, and combine two major parts. Tall oil fatty acid is a carbon 18 aliphatic acid, very flexible material. Another side is tall oil rosin. It also have different isomers and rigid ring structure. When you look at this rosin chemistry, there are two sets you can do the chemical modification or reaction. On the bottom part is COOH, carboxylic acid group. They can react with a glycol to make ester. Also can react with amine to make amide, but they need a relatively high temperature because the reactivity not that high. Another cell you can see this conjugate double bonds can go through that outer reaction with fumaric or maleic to introduce additional functionalities. But they only have up to 50% more in rosin compositions. So overall, tall oil rosin is a hard and brittle material. There are numbers of isomers and hard to handle because it's room temperature solid. And the good thing is the carboxylic acid group is easy to react with epoxy group at elevated temperature. People know epoxy is a high reactive function group that can react with amine, acid, free radical, ionic, almost everything. Also, this rosin is longevity in-house raw material. Again, DTO is good balance, the hardness from rosin and the flexibility from tall oil fatty acid. Talking about 2K epoxy, the part A, the epoxy resin. I show you here this several commercial available epoxy resin in the market. EPON A2A is a trade name from Hexion, and people also called bisphenol A epoxy or liquid epoxy. It's a major epoxy resin in the market. Let's see, maybe 90% the epoxy market using this material or to modify this material. And the DN438, second one is Nova-like epoxy with functionality somewhere around 3.6. And I using this material a lot in the past to increase heat resistance and physical properties. It's a region from Dow Chemical, right now called Olin. And the bottom part, this epoxy is multifunctional epoxy dilute, TMP tri-epoxy. They also have a mono epoxy dilute called epoxide 8 or Glidex N10, difunctional epoxy dilute MPG epoxy, and they have numbers of different products. So part B is hardeners. There are so many different hardeners market, but most hardener can fall into the following categories. Aliphatic amine hardeners, mostly used for room temperature or even lower temperature cure. Cycloaliphatic amine hardeners, majorly used for chemical resistant applications, but more expensive. Polyamide and the middle amine is a good balance, performance, and cost. Anhydride and Dicy are both used for elevated temperature cure. Dicy plus catalyst, mostly used like urea or anhydride for pre-preg application, as far as I know. The property people interested in is mix ratio. Ideal mix ratio is 1:1 or 2:1 epoxy to harness. And also initial mix viscosity. Because epoxy, when the part A and part B blend together, and the viscosity starting to increase. So people care about what initial viscosity is. And also gel time and shelf life, cure time, and cure properties. Cure properties important, include like glass transition temperature, and physical property, and so on. Now let's talking about an longevity new DTO-based epoxy reagents. The Ultimer is an longevity trade name for bio-based monomers and ligamers. Okay, Autorize is a longevity trade name for new bio-based polymers and reagents and formulated materials ready to use. So you can see the first table, we developed 3 Ultimer EP epoxy, EP100, EP125, and EP150, the all DTO-based epoxy rate. Bio content range from 42% to 47%, EW from 500 to over 600, and they are room temperature viscous liquid, and viscosity we measure at 50 Celsius from 1,000 to somewhere 4,700 centipoise. So this is a picture show you what it look like, the EPI epoxy. And then we made this Ultra series epoxy. It's called formulated detailed epoxy, starting with an EP material and with another epoxy like EPON828, and make this 3 Ultra and reagents. It's ready to use. So you can use this material for your applications. And the bio content from 20% to 24%, and EW from 250 to 300, and the viscosity at 50C is from 650 centipoise to over 1,000. And this is the basic detailed epoxy reagent properties. This slide starts showing the kiln properties. The first kiln agent we use in this polyetheramine, geframine, from Huntsman called T403. And this first table shows this initial viscosity, like I mentioned before, somewhere around like 300 to 500. And gel time, we're using a EPON828 traditional epoxy as benchmark that compare how our detailed epoxy look like and have some benchmark for comparison purpose. So the gel time is shorter compared to EPON 828 benchmark, and the cure time pretty similar. When you look at the peak isothermal temperature, our detailed epoxy have about 36 lower the peak thermal temperature compared to a benchmark EPON 828. In some application, the lower peak isothermal temperature is a benefit. Example for synthetic foam or tooling applications. The people really looking for relatively lower peak isothermal temperature, but the material is completely cured. The reason for that, the higher peak isothermal temperature generate higher internal stress and cause some micro cracking. Under pressure, there's potential problems. So this is a potential maybe have some benefit for this type of applications. Now, last column is coating properties. The tag-free time and compared to benchmark, it's pretty similar. So epoxy people also interested for thermal and physical properties. This is the same Hanner and Jefferman T403, and we made the clear casting samples and testing for tensile property and the DMATGs. So modulus, you compare benchmark EPON 828, pretty similar, not major difference. And tensile strength and elongation slightly lower, but still feel comfortable in most applications. And TG is lower by about 26. The second part I talk is detailed epoxy cure with anhydride. So anhydride we use here is MHHPA, as so the structure in the bottom. And the more ratio anhydride to epoxy is 0.9 to 1 more ratio. We're also using 3% the catalyst DMP.30. I also show you structure on the bottom part. And this catalyst also called K54, or people also called anchormine. It's a common use catalyst for epoxy curing. Again, we're using EPON 828 and bisphenol epoxy as benchmark only for comparison how we feel comfortable for our detailed epoxy performance. The curing condition 3 hours at 120 C and followed by 3 hours post-cure at 150 C. Water absorption for epoxy application always important properties, because epoxy reagent when they cured will be generate not secondary hydroxy group. Its potential pick up the waters. We're doing this water absorption test by immersion test, okay, from 3 days up to 4 weeks. The blue line represents a benchmark EPON 828, and the lower the 3 line is our detailed epoxies. From the chart, you can clearly see with increased time, the difference has become bigger and bigger. At 4 weeks, our detailed epoxy has significantly reduced water absorption compared to the benchmark EPON 828. See more than 50% reduction for water absorptions. It is a very good news. So this is a coating film on glass panels. On the left-hand side is the benchmark bisphenol epoxy control. You can see some after post-cure has some cracking in the surface. The right-hand side is our detailed epoxy rate. It's very smooth and glossy, transparent, and coating film. We also look at this adhesion evaluation by IceCard type test. And the 0A represent the totally failed. It's not, don't have much adhesion on the substrate. 5A represents best adhesion on the substrate. Okay. So here is a comparison of glass adhesion, the benchmark, and with our detailed epoxy. You can see the control DGEB8 is another name for EPOX8. It totally failed on the glass adhesion in this specific condition of hardness at post-cure. Our detailed epoxy so significantly improved adhesion on glass from a 0A benchmark jump to 4As. So now let's look at how many percent detailed epoxy in the formulation can see improvement for adhesion on glass substrate. We're adding 10%, 20%, 30%, 40% detailed epoxy into bisphenol epoxy, and then we made the same test. So you can see 10% detailed epoxy in the formulation, you can start seeing improvement for adhesions from 0A control to 2As. When you increase detailed epoxy to 30% in the formulation, you can see significant improve adhesion from 0A to 4As. Another interesting thing we found out is color stability at a high temperature. Like post-cure, this epoxy sits at 150 C for 3 hours, and the control sample so much dark color than our detailed epoxy at same temperature. So this may suggest us detailed epoxy rate may have a good UV resistance, but we don't have data, we don't have tests so far. We're going to do the test. There will be interesting area to look at. And the same question, how much percent detail in the formulation we can prove the color stability at high temperature? We're starting with 0% detail epoxy up to 50%. So you can see increase detail epoxy percentage, the color stability at a high temperature is improved significantly. So we continue working on this detail epoxy with different hardness and in the market. This is a detail epoxy cure with amidamines. You can see detail epoxy have much more compatible with amidamines compared to bisphenol epoxy, the Epox8. Left-hand side, the next 5 minutes, detail epoxy with amidamine it turned very clear. The right-hand side picture, and after cure, it's a very transparent, clear, the clear casting. Left-hand side represent the control and the bisphenol epoxy with amidamine. After 5 minutes, still hazy and not transparent. And after cure, again, this is not totally transparent and also has opaque that look like. So some films show the same trend with amidamines, and detail epoxy with amidamine. This amidamine is come from Gabriel and 140. Our detail epoxy seeds so it's very transparent and very glossy and smooth film, and the control sample show not a smooth some film. So I think this is a big improvement. And for the mandragine, the test, our detail epoxy 1042, 1043 all pass the mandragine, and so very flexible materials. And control sample, you can see they have some cracking after this mandragine test, so it failed. Ingevity recently developed a series of bio-based material. This is give you another example with starting, not details, we can starting with radons. And we develop radon mono epoxy, RME, and the radon-twine epoxy called RTE, and also have a radon methacrylate and the radon diol and the radon trials. And we also have some free radical curable and detail-based thermoset for composite applications. So we don't have time to show you here. So summary, the new bio-based detail epoxy resin offer high bio content and good reactivities, comparable surface hardness and surface cure, enhanced hydrophobicity and significant glass adhesion improvement, improved color stability at high temperature. Acknowledgement, I'd like to thank you, my colleague, Dr. Wu Ming, for doing a lot of epoxy curing study in the lab, and platform members, and Bing, Mitchell, and Tom, and Chris is our business manager. And thank you all your attention. If you like more information, you can either contact myself or Chris. And this is Chris' contact information on the bottom. Again, thank you all your attention. Any questions?
Thank you, Yongning. Excellent presentation. We do have a couple of questions. The first question is, can you explain why the Alta Res has much lower peak exotherm and higher adhesion compared to EPON 828?
Yeah, and detail epoxy, we outright have relatively lower peak isothermal temperature because we believe we have a less cross-linking density. And you can tell from the EW. And adhesion, I think this is very unique properties because probably this different substrate and detail have a better, in the surface and contact with the substrate. We not only for the glass substrate, we're doing a lot of tests. Right now, we found also have better adhesion on alumina panel and metals. So we don't have the time to show you here, but we have the data. So it's already showed better adhesions in different substrate for detail epoxy compared to bisphenol epoxy.
Thank you. The second question is, how does the adhesion on metal surfaces compare?
Yeah, this is, I think I mentioned, and in metal and alumina, we see the same trend. Detail epoxy shows better adhesion if compared to bisphenol epoxy EPON 828 with the same curing reagent like anhydride middle means.
Thank you, Yongning. And how do the Alta-Res products compare to 828 in dielectric strength?
You mean dielectric strength?
Yes.
We don't have this data. We don't testing for dielectric strength. We only test for tensile strength right now.
Okay. And what are the RT densities of the materials?
Good question. We are going to measure that, but we don't have the data yet at this moment.
Thank you. And in slide 11, is the cure time and gel time reversed? Typically, the gel time is shorter than the cure time.
Good question. By definition, because I work on the composite area a long time, and gel time and cure time, by definitions, cure time, if people call the total time, definitely longer because from gel time plus cure times equal the total time. And for some definition in this table, we call the cure time, it's starting time when they reach gel, it start timer. When they reach this peak at the certain, we stop the timer. This is we put the number here to count cure time. Okay. So I think this is most people report should be called the total time. This is gel time plus cure time. So if you see this way, will be definitely this will be longer than gel time.
Thank you. And one more question, is Altarez a glycidyl ester type epoxy?
I'm sorry, say one more time.
Is Altarez a glycidyl ester type epoxy?
Yes.
Excellent. Thank you very much for your presentation, and thank you for answering the questions submitted by our audience. Does anyone else have any questions? Please feel free to submit them now via the questions feature. Thank you.
Thank you, Rick.
Thank you very much. Thank you everyone for attending. We will post the recording of this presentation on the website later today. Thank you all for attending.
Thanks.